All right, good morning, everyone. My name is Emily Adrid with the Colorado Water Conservation Board. Welcome to the April 2026 Water Conditions Monitoring Committee. Today, we will have presentations from the Colorado Climate Center and NRCS. Um, but before we get into the presentations, I just wanted to provide a quick update on the Drought Task Force. In our last meeting, we had Nate Pearson from the Department of Natural Resources come to our meeting and announce that the governor activated the state's drought task force, which is meant to elevate and identify local, regional, or sector-specific impacts of drought and make potential recommendations to the governor. Um, and the Drought Task Force had their first meeting on April 10th. And the Drought Task Force is made up of senior leadership from key water-focused state agencies, including the Department of Natural Resources, Department of Agriculture, Department of Local Affairs, and Division of Homeland Security and Emergency Management. So um, I will put a link in the chat to the Drought Task Force website where you can find a meeting summary and then a recording of the meeting as well. So, with that, I think I will pass it over to Peter.
Good morning, Emily. Thank you so much, and thanks for the update on the Drought Task Force.
Yeah.
Let's see here. I will go ahead and share my screen. Um, go with that screen. I believe you should be seeing a Climate Prediction Center graphic, but we're going to change that in just a moment. And now you should be seeing my slides. Are we good?
I'm still seeing the Climate Prediction Center.
Well, shoot. Okay. Let's try this. Okay, now you should be seeing something in not quite in slideshow mode. What about now? Uh,
Um, Seeing it in presenter mode.
let's see, still presenter mode?
Yes.
Shoot. Okay. Let's try.
Angela said in the chat, try swap displays. There we
How's
go.
that?
Okay. Yep. That works.
Like the eye doctor, better or worse? Okay, great. Thank you so much. Yeah, my name is Peter Goebel. I'm the assistant state climatologist with the Colorado Climate Center, for those who may not have met. And today I'm going to be giving an update on recent climate conditions around Colorado, recent drought conditions. We just got that great update on the Drought Task Force. And then a quick look forward at what might be coming in the weeks and months ahead. A lot of folks have been talking about Super El Nino. We're going to talk about it today. This is a photo from last Friday when the Book Cliffs got dusted with snow, taken from the Western Research Center with CSU in Grand Junction. All right, so agenda for today. Start with the climate conditions update, then the drought update, then the seasonal weather outlook. And I showed this map last month and just wanted to show an update because it's been such a strange year, not only climatologically, but phenologically, and certainly the two go together. But this is a look at how much earlier we saw bud break on trees and plants versus a normal year. And most of the state was about 3 weeks early, if not even a little bit earlier. I was in Vail in late March, and you were already seeing some budding on the trees in late March. Okay, so we'll start with one of our quadrant charts, and this is looking at March conditions statewide. And this graphic and many of the others that I'll show are using data from the NOAA National Centers for Environmental Information NCLIME grid product. And that is a statewide temperature and precipitation mapping product that goes back to 1895. And most of the data that are in these graphics come from long-term cooperative observer network weather stations. So that's where the data comes from. Here's what the data show. The horizontal axis shows the accumulated precipitation for the month of March. The vertical axis shows the average temperature, and these are averaged statewide spatially. And each dot shows a given year, and each dot is labeled. And you can see 2026 way up in that upper left quadrant, standing apart. So it was 9.8 Fahrenheit above the 1991 through 2020 normal. Easily the warmest March on record with that amazing heat wave that we saw in the third week of March, and some similar conditions in the fourth week of March. And then it was also one of our driest marches on record, almost an inch below normal statewide for precipitation, with some areas seeing nearly nothing or nothing in the month of March. Here is a graphic showing the departure from normal temperatures for March, and you can see here that again 9.8 above the 91 through 2020 average, 13 degrees above the 20th century average, with many areas showing over 10 degrees above that 30-year, most recent 30-year normal. And if we look at how this ranks compared to other marches on record, this is not a misprint. It was the warmest march on record everywhere across the state. This is very unusual to see. Here are the departure from normal temperatures for the month of April to date. And April has also been warmer than the 91 through 2020 averages, but it's at least been closer to what we would see in a typical April. A normal April, of course, is warmer than a normal March, and our temperatures for the first half of April have been cooler than the second half of March, but still above normal. Statewide, we're running right around 4 degrees, maybe a little less than that, above normal for the month of April. Some places a little bit higher than that, some places a little bit lower. Okay, here is a look at March precipitation percent of the 91 through 2020 normal. And you can see quite a bit of area in southeastern Colorado that was below 10% of normal. Most of the state well below normal, including the mountains where, of course, snowpack was already tracking at near to record lows throughout much of the state going into March. The month of March made things much worse, but I think it's also quite notable what we're seeing on the Eastern Plains, where the Eastern Plains climatologically are very dry in December through February. So when winter conditions are dry, you worry, but maybe not as much as some other areas. But once you get into the month of March, you really do expect precipitation rates to pick up on the eastern plains. And that, for the most part, failed to happen. And so we have seen, and we're going to see this in the drought maps later, that there's been significant degradation on the eastern plains as well. Here is how things rank compared to the other 132 years of record. And we see that there were some areas where we had a record dry March, like the southeast corner of the state. Um, the area that was a little bit better was, for the most part, the urban corridor from Fort Collins down to Pueblo and extending a little bit out onto the Eastern Plains, but not fully out onto the Eastern Plains. And that's really from one storm, kind of the end of that first week of March. We had a decent snowstorm before things turned historically warm and dry. Let's see, this is precipitation for the month of April to date, and it's overlaid against the current U.S. Drought Monitor map. So the contours that are not filled, the kind of red and orange contours that are not filled, those are current Drought Monitor contours. We're going to get a better look at that in a few slides. So don't strain yourself to try to figure out what that's showing. What I want folks to focus on in this map is the filled contours, and the legend for that is on the right-hand side, where you can see how much precipitation has fallen for the month to date. And you'll notice that there are some areas where things look a little bit more positive than what we saw in March, or frankly, quite a few of the months before March. We have had some decent moisture on the west slope for the month of April to date. And, that didn't really overall change the big picture narrative of the winter season in Western Colorado, but we'll certainly take what we can get. And these storms have helped somewhat with just putting our water supply in a little bit better, but still very poor shape. And then if we look at Eastern Colorado, for the most part, numbers have been low around the metro area, a little bit better, closer to half an inch of moisture for the month of April to date. We're two-thirds of the way through April. Half an inch of moisture through the first two-thirds of April is still well below normal because, again, for eastern Colorado up to and including the Front Range, we expect precipitation to pick up. This is supposed to be kind of the start of our wet season on the Front Range and on the Eastern Plains, and it's been slow getting started. We haven't had that good spring moisture yet east of the Continental Divide. This is a look at a kind of a time series showing how water year 2026 has compared to a normal water year, both in terms of temperature and precipitation. So I'll draw your attention to the upper part of this graphic first, which shows a time series. That upper plot shows the time of year starting October 1st. So we're looking at the water year on the horizontal axis and the statewide average temperature on the vertical axis. The black line shows our 91 through 2020 averages, and then each bar represents a single day of observations in 2026. And so the bars that are red are where it's been warmer than normal, and the blues are cooler than normal. You can see we had about one good week of winter in late January, a little bit more late February, but the story has certainly been warm, warm, warm throughout the winter, and definitely that continued in March, with December and March really leaping off the charts there. And if we look at the plots just below that, it shows graphics across the state of how much warmer or cooler than normal it was, and the overall rank relative to that time series going back to 1895. And so you see that we've had three record warm months out of 6 months, with another one that's in the top five, and all six in the top 20 out of over 130 years of record. So shattering records for warmest start to the water year. If we look at precipitation, not quite as dramatic, but you still definitely see the fingerprint of a developing uh, serious drought. And so the first plot there on the bottom graphic shows uh, again time on the horizontal axis, and the cumulative precipitation anomaly averaged statewide on the vertical axis. So, of course, we start at zero at the beginning of the water year, and then we had flooding conditions in southwest Colorado that bumped us up above normal in mid-October. Even though other parts of the state at that time were dry, the concentrated but very extreme wetter than normal conditions in one area of the state bumped up the statewide average. And then you can see it's been a long, relatively steady decline since then through the middle of April. We can see that from the end of March to where we are in April now, things haven't declined that much because of some of the better moisture that we've had on the west side of the Continental Divide, but we have certainly continued to dry out east of the Continental Divide. And then the maps below that show you by month how the spatial pattern of precipitation broke out for each month. And you can see that every month from November through March statewide has been drier than normal. And even if you look at that first month in the time series, October, while it was wetter than normal statewide, you can certainly see east of the Continental Divide that it was not wet everywhere. All right, these are some of the numbers from our heat wave in March. And so the plot on the left-hand side shows the number of days in March with a high temperature that was greater than the previous March monthly record for 1951 through 2025. And so we have quite a few areas that broke their previous March monthly high temperature record uh, as many as 7 or more days. I believe, even though it's not super clear on this map, I believe our Fort Collins weather station, we broke it on 8 separate days. Our previous monthly record was 81. We got all the way to 91. And you can see in the table on the right-hand side some of the different areas around the state what the previous March record was and what the new record was set in 2026, including areas where we set a new record, monthly record high temperature by over 10 degrees, which to break your previous extreme with 75 years of data by over 10 degrees really underscores just how anomalous this March heat wave was. Here are some of the statewide extremes that we saw in March. I wanted to show this slide primarily because there were two areas that set a new statewide highest temperature record for the month of March. We didn't quite hit 100, but we almost did in two separate places. Campo down in southeastern Colorado hit 99 on March 27th. Burlington hit 99 on March 26th. And then you can see some of the other state extremes around the state. Hebron, the Coagmet in North Park, hit minus 17 on March 7th. That's probably, well, it is much closer to a normal um, cold statewide extreme than the high records, where those really are much higher than we would see in a normal March. They were indeed records. All right, with that, I'll transition into some of our current drought conditions. So everything that I've showed so far hopefully helps underscore why the U.S. Drought Monitor map currently looks like this. Right now, we're seeing 98% of the state in moderate drought or worse, or D1 conditions or worse, and 54% of the state in severe to exceptional drought. So, just to give folks a little bit of a primer on what that means, moderate drought conditions are conditions that are reflective of below the 20th percentile for the standardized according to location and time of year. So you would expect to see conditions this bad or worse 1 out of every 5 years or less. And then the areas that are in red or dark red, extreme or exceptional drought, the um, lighter red is where you would expect to see things this bad 1 in every 20 years, and the dark red 1 in every 50 years. Of course, that assumes a stable climate, which we do not have. Um, but there we are certainly in quite anomalous water balance conditions right now. Here's how much things have classifications on the US drought map have changed over the last 12 weeks. So the areas in orange are areas that have been degraded 3 classes. You see quite a bit of that on the map. Areas in the kind of lighter yellow means 1 class. The area in in the darker yellowish orange, 2 classes, and then we do have one area down in southern Colorado where you see as much as a 4 class degradation over the last 12 weeks. And then this is the last year. And so here you can see that much of the area that is in D4 drought now was not in drought this time a year ago. A 5 class degradation is really as much as you can show here. All right, this is a look. We're going to now look at standardized precipitation indices for a couple different time scales as well as some land surface metrics. So this is a look at 90-day standardized precipitation index, which is a measure of how rare it is for precipitation to be as much or above or below normal as it has been over the, in this case, last 90 days. But you can compute this for any window of time. The colors are designed, at least on the dry side of the scale, to match the US Drought Monitor's percentile classification scheme. And so the areas that are in red or dark red, you can think about the same rule of thumb that I gave on the US Drought Monitor map. There is a wet side to this color scheme with greens and blues and purples, but we don't see any of that on the map right now because statewide we just have not had any areas with wetter than normal conditions over the last 90 days. But I do really want to look at the eastern plains here where you can see some pretty wide swaths where things have been much drier than normal. And like I said, we're getting into the time of year where this is really becoming a problem because we're getting into the time of year where we should be transitioning into the wet season. And just from an agricultural impact standpoint, you really want a few $1 million rains to put down on the ground going into the growing season, whether that's to moisten up the soils before planting or to help with the winter wheat that is greening up and greened up early this year. Here's a look at essentially the last year, and it's 360 days, so not quite a year in terms of precipitation. And this should help explain the big bullseye that you saw on the drought map in the north central and northwestern Rockies, where you see D4 conditions. And this is an area where not only has winter snowpack been near at record lows, but last summer was also critically warm and dry. If we think back to um, the Lee fire, we saw some very dry conditions around the middle of summer. Things abated a bit in late August and into September, where we did have some rains over that time frame, but really dry summer, and then of course we all know that the winter was in many places record low snowpack. Eastern plains are a little bit trickier, right? Because we did have a good growing season last year. We had wetter than normal conditions throughout much of last summer, but for the last 6 months, it's been mostly very dry, and so we're we're seeing the impacts of that now. All right, here's a look at soil moisture in the top meter from our NASA produced Western Land Data Assimilation Systems model. And again, here the color scheme on the dry side is designed to match the US drought monitor. We do have some areas with wetter than normal soils, but you'll notice where those wetter soils are. It's over our high elevations. And this is not because it's been um, wetter than normal. It's because we've had snow melt earlier than normal. And so you have this pulse of moisture going into the soils earlier than you would like to see it. Ideally, we would like to see this moisture still in the form of snow at those elevations. Or, we're kind of mid-April now. This map is from April 16th. So yeah, sure, you're going to be starting to see things melt even at higher elevations by mid-April, but still the signal is primarily from the soils being recharged earlier. And then trying to sort of arbitrate between the longer term wet conditions and the short term drier conditions on the eastern plains. Obviously, the wet conditions last summer were great for last growing season, but now we are seeing that soils have really dried out on the eastern plains. So you see that signal there. And then areas of western Colorado that are at lower elevations are also primarily showing below normal soil moisture. This is a graphic showing terrestrial water storage, which is a combination of snowpack, soil moisture, groundwater, and canopy moisture. Canopy moisture is, for the most part, negligible in Colorado. But here, the big story I'd say is snowpack and groundwater. And the groundwater data, it's derived from the NASA GRACE satellite, which is a gravity measurement of groundwater, where based on perturbations in the Earth's gravitational field, you can back out how much water is in some of those aquifers compared to a normal year. That's what's driving this depiction. And so we do have a long-term groundwater drying trend both in eastern Colorado and in the San Luis Valley. One thing that's worth noting, you don't see any dark red on this picture, but that's only because we don't have enough years of record for anything to get down into the dark red range. All right. So that's going to wrap up the current conditions. Now we'll go ahead and take a look at the outlook for spring, which hopefully is a little bit, I can say it is more optimistic than what I've presented so far, which is really nice because it does get a little bit taxing continuing to show degrading water supply conditions. Here's a look at the next 7 days of moisture. This is not necessarily where things turn for the better, but here we're just looking at the precipitation anomalies forecast for the next 7 days. Anywhere in brown, we're expecting below normal precipitation. In the blue-green is where we're expecting above normal precipitation. And so, a couple things. First off, we've got a storm system that'll kind of track across the northern Rockies Wednesday night into Thursday. That system is going to move through pretty well to the north of us and not have a lot of moisture in it, but likely bring some wind. But then there will be another kind of secondary low pressure circulation that dips further south this weekend with colder temperatures this weekend and hopefully some moisture, including for the metro area and the Northern Rockies, which really it's what's going on this weekend, is why you see some areas on the map with at least slightly wetter than normal or wetter than normal conditions forecast for the next 7 days. That'll cool things down this weekend with a chance of some snow even at lower elevations. And then if we move to the 8 to 14 day time frame, Here on the right-hand side, we're looking at a probabilistic temperature outlook. And on the, sorry, left-hand side, and on the right-hand side, we're looking at a probabilistic precip outlook. So starting with the temperature on the left-hand side, for the western two-thirds of our state, are looking at an increased probability of near normal temperatures with a slightly increased tilt towards below normal temperatures end of April into May for eastern Colorado. And then on the right-hand side, you see an increased probability of above normal moisture across the entire state. And right now, weather models do show a pretty substantial pattern shift to more kind of low pressure developing across much of the central and south central US, bringing down some cooler air from the north and even wrapping in some moisture. And this is the 8 to 14 day time frame, so it's a little bit early for saying how much we might be above normal. As of my glance at the models this morning, I didn't necessarily see like a big rainstorm or big blizzard in there. It just looked like it was going to be kind of on the average overall cooler and wetter with a couple different shots for a dose of moisture. And so that's really great to see this pattern shift towards more opportunities for rain or snow in these April Water Conditions Monitoring Committee meetings, I always like to try to make a guess as to whether or not we'll see snow in May at lower elevations, like around the Front Range. And some years I come in confident that we're done with snow. For as non-snowy as this year has been, this is not one of those years. I think that we could see snowfall in May this year based on what we're seeing in terms of this pattern shift in the weather models, and I hope we do. All right, so once you get beyond that 8 to 14 day time frame, you lose your ability to predict individual storms with these numerical weather models, but you can get an idea of how the probabilities might be tilted based on statistical relationships between what's going on in other slower moving parts of the climate system, often talking about ocean surface temperature patterns and what's going on with El Nino versus La Nina, and how that tends to impact our weather over Colorado. So this is a map showing sea surface temperature anomalies. Areas where you have oranges and reds are where we have warmer than normal sea surface temperatures, and areas in blue are where we have cooler than normal. And if you focus on the central and eastern equatorial Pacific Ocean, you'll notice that the cold anomalies that are the calling card of La Nina are gone. The La Nina that we've had is over, and it is likely that an El Nino is developing. If you look just off the coast of South America, you can see warmer than normal sea surface temperatures developing there. It's likely that this is going to grow into an El Nino event, and it might be a big one. So right now we have still neutral conditions, but there is a 60 plus percent chance that throughout the May, June, July timeframe, sea surface temperatures get warm enough over the eastern equatorial Pacific that we tip over the threshold into El Nino conditions. And there's a greater than 90% chance that El Nino develops by fall and will likely stay through next winter. So that matters because it affects the strength of the tropical trade winds, which in turn has an impact on the polar jet stream in the northern hemisphere, which is the upper atmosphere current of air that are high and low pressure systems that you see on the weather map on the news ride along. And so if you change the kind of mean patterns of those currents of air, it can impact our weather. And here are the general impacts by season of El Nino versus La Nina in Colorado. And so here we're looking in the upper left at December, January, February, or winter, upper right, March, April, May, or spring, Lower left, summer, lower right, fall. Areas in red tend to be wetter during El Nino. Areas in blue tend to be wetter during La Nina. I think the upper left is a really good example of how much uncertainty there is here because our northern Rockies, our north central Rockies especially, tend to be wetter during winter during a La Nina. We had a weak La Nina over the last winter and it was obviously much drier than normal for many record dry. And in fact, I wonder once 2026 gets added to this data set, if you'll still even see the blue in the upper right graphic. But if this pattern does hold, if you look at June, July, August, and September, October, November, when we're hopefully going to have El Nino conditions in place, most of the state tends wetter during El Nino. And so this is hopefully a sign that things could turn for the better this summer into this fall. There's been a lot of discussion of a super El Nino, which is where our sea surface temperatures in the eastern and central Pacific are at least 2 Celsius above normal. There's a good chance that this ends up being a super El Nino with the dynamical model average from the International Research Institute being right around 2C. So if the dynamical model average is right around that threshold, there's a decent shot that we get there. I do want to mention, and I've been saying this a lot, there's nothing magical about that super threshold of 2C, where if we tip into super, it's going to suddenly do something amazing. That's just not the case. But it does make us the more pronounced the pattern, the closer we can be to confident in some of these effects on precipitation. We only have a 3-year sample of super El Ninos. Two of them were very good snow years, and one of them was an average snow year if we're looking all the way out to next winter. But overall, I don't think we're looking out quite that far yet. For this summer, it does help our odds of a wetter than normal summer. Here's the seasonal outlook from the Climate Prediction Center for May, June, July. And I'm going to show June, July, August in a minute, which shows something very different. But here, again, left-hand side shows temperature, right-hand side shows precipitation. We do see an increased probability of above normal temperatures across the state. And this is primarily driven by just long-term temperature trends. And during summer, we see less year-to-year variability in temperature. So if you have a strong trend and low, relatively anyway, low year-to-year variation, then it's hard to escape increased probabilities of above normal temperatures once you get into summer. And so that's what we're seeing there is really a reflection of that. On the right-hand side, I actually have some questions because we do see on the CPC map an increased probability of below normal moisture for May, June, July for northern Colorado, and we see an increased probability of above normal moisture just tipping into southern Colorado. Now, if this was an increased probability of below normal moisture based on lingering impacts from La Nina, maybe over northern Colorado, I could maybe buy it. But the Climate Prediction Center's outlook for May shows equal chances of above and below normal precipitation, and their outlook for July, August, September shows above normal across basically the entire state. So I don't know if this is just a June thing specifically in a couple of their dynamical models, but the slight tilt towards below normal precip doesn't really match well with their own May forecast. It doesn't really match well with their forecast for the back end of this period either. And so it's a bit of a head scratcher to me. And I'm not quite as confident in that, especially given that the pattern looks like it's starting to shift and the first half of May could be pretty good. When we get into summer, yeah, this makes a little bit more sense to me, not just because of El Nino and the fact that it could be a strong El Nino, but also because many of the dynamical models that go into these forecasts are showing a strong possibility of an active monsoon season. And so you see that bullseye in increased probability of above normal moisture over the Four Corners region. Again, we do see an increased probability of above normal temperatures for July, August, September. And again, that's strongly linked to temperature trends. One thing that's worth noting is if we do have an active monsoon year, usually that comes with stronger than normal high pressure over the south central plains, which is why you see an increased tilt towards below normal precip there. If the pattern just shifts a little bit to the west, you could see this play out in a way that's not so good for the far east reaches of Colorado, but this does look better, at least for western and probably central Colorado going into the mid to late summer. And so this does lead to some interesting implications for summer impacts. For one, we are, because of the low snowpack and early snow melt, we are going into the summer season, likely at least the first half of it, with increased probabilities of wildfires. But then by the second half, if this forecast between the strong El Nino verifying and or the strong monsoon verifying, we could end up in August talking about increased probabilities of flooding, potentially even on fresh burn scars. So those are just some potential impacts to watch going forward based on how some of these weather models are leaning. All right, I have a few takeaways here. Not going to read through all of this. March was obviously historically warm. Temperatures have cooled a bit, but they're still above normal. We've seen a little bit of reprieve in western Colorado, but worsening conditions in eastern Colorado. Overall, between the very low snowpack and the warm, dry winter and start to spring on the plains, we are in drought conditions across basically the entire state, and they at this time are worsening. But this is probably the most optimistic seasonal outlook that I've been able to give on one of these calls in quite some time. So, with La Nina being over and El Nino likely to develop and come on strong, and some of these dynamical models showing a good chance of an active monsoon. Maybe in the next couple of months things start to turn for the better in terms of moisture. Of course, when it comes to our water supply, I think that the damage is kind of already done where our water supplies, our major reservoirs are going to take large hits this year with the record low snowpack. But above normal moisture for summer at this point, if it does verify, we would certainly take it. So I'll wrap up there. Thank you so much for your time this morning and have a great rest of your day. If there's any questions, happy to take those.
Thanks, Peter. I think there is a question in the chat, but I
Sure.
think for the sake of time, if you wouldn't mind just replying to it in the chat, that would be awesome.
Yeah, I can do
Um,
that.
awesome. Um, well, gonna hold on to a little nugget of hope about the El Nino, but I agree it is pretty taxing to hear all of these pretty terrible conditions every meeting. So I appreciate that update, Peter. And then I will pass it to Brian now from NRCS.
Yes, thank you, Emily. Can you all hear me all right?
Yes.
Great. Gonna get the presentation going here and switch displays. All right. Oh, and I need to share my screen, excuse me. All right, now going to switch. Okay. Can you see The
Yes.
presenter screen or the main slides?
Main slides. You're good.
Awesome. Thank you. All
Yep.
right. So yeah, this does get great word, Peter, taxing, presenting poor conditions. And usually I start to transition uh, towards less snowpack slides and more simply precipitation slides come, you know, July, a month or two after snowpack has really melted out. But I'll probably continue to dwell on these at least for another month when we typically have snowpack. So it remains taxing at least for this month and maybe next month. But there is a little bit of glimmer of hope, not just in Peter's forecasts looking forward for the next few weeks and into the summer. But we've also seen those temps cool off, which has had an impact on our snowpack in Colorado, and I'll get into that here shortly. I do have a lot of slides to go through. I mainly put those slides in there to hit on a few nuances of some of the basins and to also make it available to anybody who wants to look at the slide deck after the presentation, just so all of the resources are there, but we'll get into that. So go ahead and or we're going to start off here and look at snowpack across the state. As it's been mentioned both in previous months and just earlier today in Peter's presentation, snowpack is of course not looking very great. It's kind of hard to make out here in with all of the red that we're seeing. But if you look at some of the numbers, particularly in the southern half and the southeastern mountains, such as the Sangre de Cristos in this area, snowpack is essentially gone. There's a few sites with some snow up high. And at the locations where snowpack winds up retaining for wind redistribution reasons or whatnot, most of the snowpack across the state is gone or mostly gone for that point. Again, we'll get into that here shortly. But there are some locations that are holding on to snow, particularly in the northern half of the state. I think it's hard not to talk about Cochetoba Pass Snowtel right here, which is showing 150% of normal. But this is just kind of a mathematical highlight here in that there's typically very little snow at this site this time of year. And right now we have a little bit more snow than is typical. I think there's like, say, an inch and a half of snow water equivalent there when there's typically, say, an inch of water equivalent. And that's why we're seeing 150% of normal. I'm pretty sure it is true. And that's actually thanks to some of the snow and precipitation that we received about a week ago and earlier in April that Peter pointed out. And I'll get into that here in a little bit. Okay, so zooming out and looking at the rest of the country, again, I kind of like to put it into perspective. Yeah, here in Colorado, not doing great for snowpack, but really neither is much of the rest of the country, all the way up through Oregon, much of Washington, Salt Lake, or excuse me, Utah is seeing the same depleted snowpacks that we are. Southern Idaho, it's the portions of western Montana, eastern Idaho that are seeing more near normal snowpack, but for the most part, still below to well below normal. In this slide, I'm trying to draw a comparison between, or actually just the change from the presentation last month, where this is the snowpack that we were seeing slightly better in the northern half of the state, near 70% to 60%, and then below 50% in the southwestern portion of the state, to now this month, looking at it from a larger basin standpoint, as opposed to the last two slides. Snowpack is well below normal with just a few sites holding on to snow. There are some sites, like I mentioned, that are still holding on to snow, but it is relatively small. But it is thanks in part to the cooler temps that we have seen in April. And I'll point that out here in a little bit, as Peter already has. I just wanted to point out the actual sites that still do, for the most part, have snow. It's kind of hard to make out here, but the sites that do still have snow are the ones that have colored dots. The sites that have essentially the white coloration have no snow anymore. And it's not entirely elevation based, so it's not all of the high elevation sites, but it is the sites that typically hold on to snow because of their placement within the basin, being on east-facing slopes, east-south facing slopes that tend to hold on to snow a little bit more. We do try to select sites that hold on to snow just simply because they give us a better idea of what happens later on in the winter, and those are the snow or the hydrograph driving regions of the basins. So there are some sites that still have, under 10 inches of snow water equivalent at them. And they are somewhat scattered throughout the state, but still, I'll go back to that slide, but still favorable, or excuse me, more sites in the northern half of the state, less so in the southern and the Sangre de Cristos, which are typically drier, are pretty much melted out. So it was about April 1 where cooler temps, or more seasonal temps, I should say, have prevailed. But it still, as Peter has mentioned, is above normal. But it has helped out a lot. You can actually see the inflection here. We were seeing those well above normal temps in late March, even early March, and it really started to drive snowpack melt. And then almost like a switch on April 1, things cooled off. We received some precipitation that wound up boosting snowpack. Mostly it fell as snow in many basins. At the lower elevation, not quite so much, but we still saw a boost, and we have seen those cooler temps fall as the just more recent storms fall as snow in the last 21 days. Snowpack as of this morning is 19% of median, and that, of course, is right here in the black line, still well below the minimum, which was 2002 or 1981, depending on which graphic you're looking at, a tool you're using, because of the numerical requirements that we have on our tools. And still in the minimum. This is a separate tool that I resurrected because the standard online or publicly available tools do not show 1981. This tool does allow us to show 1981. And you can see 1981 here is actually kind of aligns quite closely with 2002, 2012. On about May 1, we're not quite there yet, but in 1981, we did have some very high melt rates as we returned back to warm after a snowy March and early April. So I've had a number of people asking me, is there a possibility that we could return to normal snowpack? It is possible if we stay cooler than we had been earlier in March. We don't want those 90-degree temps, at least down in the plains and in the valleys. If we can keep nighttime temps closer to freezing, we're going to continue to hold on to some of this snowpack, but it's hard once we've started to see melt like this. But it is possible if we see more storms, which it sounds like we may. The question is how much will we receive? Those boosts, like we saw here, can help kind of return snowpack at least a bit more to normal. But of course, it's worth pointing out that our snowpack peak was nowhere near the normal, which is right here along this dotted line. And that's, as Peter said, where the real impacts are to summer and spring runoff. We are just not going to see that runoff, and I'll get to that here in some future slides. Like I was just mentioning, kind of what are the prospects going back to last month during the presentation. Here were the potential scenarios, accumulations that we could see in terms of what we've seen in the past, what those analogs look like. A lot more potential for more snow. At this point, over here on the right side, we really don't see anywhere near as much potential for sizable storms to really make an impact on our snowpack, and that's been reported in the media. But these storms, if we do see some improvement, can make a real impact. It's just not really going to boost our water supply throughout the rest of the summer. But as Peter mentioned, these are the wetter months, especially here on the Front Range. Really would like to see that precip, so that is a good glimmer of hope that he mentioned. I wanted to highlight our monthly data, which has been extremely helpful this year in putting our snowpack into context, not just through the daily SNOTEL record going back to about 1981 or 1987, depending on which basin you're looking at, but the snow course monthly record. The snow courses are measured every month. Go back in some cases to 1936. That we started to have a robust number of sites in about 1941, where I could put some numbers together for the entire state of Colorado. But you can see how extreme and how set apart 2026 is compared to all of the historical years. I just put together the worst 3 to 4 years: 2002, 1981, 1977, and 2012. And you can see, with the exception of 2012, all of the other years were still increasing snowpack from March 1 to April 1. 2012 was higher, but you can see that the decline that we saw from March 1 to April 1 was still not as steep as what we saw in 2026 here from March 1 to April 1. So just a pretty extreme inflection and change in the warmth that we saw in March. So I'm going to dive into the individual basins, and I am going to go through these relatively fast because the conditions are relatively similar across much of the state and across much of the basins. So snowpack in the Arkansas is 9% of median as of this morning. Again, we did see some boost in snowpack, but very slight and not going to help very much in the hydrograph, really, which is something I'll get into here in a little bit. On the right is a zoomed in highlight of what the actual conditions are for each one of these years on April 21st. So I'll only mention this in this first graph. For this year, as of this morning, we had 1 inch of water equivalent in the Arkansas River Basin. And then in 2002, we had 2.1 inches of water equivalent. So just trying to draw the comparisons to all the different years. And here is the median. It might be a little bit hard to see. I think I zoomed in enough to where you can see the median for April 21st is 10.2 inches of water equivalent. And that's where you just take 1.0 divided by 10.2 to get your median. So quite low compared to where we are. And you can see for most of these basins, with a slight shift depending on where we are in the state, we are just past our typical snowpack peak. In the northern basins, in the southern basins, we typically peak earlier in April. So you'll see, say, the South Platte will be a little bit later, and the Yampa, White, and Little Snake will be a little bit later as well. So 22% of median in the Colorado headwaters. The Gunnison is 16% of median as of this morning. And you'll see that some of the years that I threw in there vary, just to highlight other low years and where snowpack was in those years compared to this year. 33% in the Laramie and North Platte combined basins. The combined San Miguel, Dolores, Animas, San Juan is 11% of median, but getting relatively close to normal. In some future graphics, I'll point out the impacts of the precipitation that we saw in April has really benefited the southern mountains more so than the northern, let's put it that way. But we're still looking at a deficit through April. And again, I'll point that out here in a little bit. And the South Platte River Basin is 25% of median snowpack. And here again, in the southern half of the state, the Upper Rio Grande is 11%, getting close to near where 2002 was, and that minimum, depending on how future storms come in. If it's snow, we might actually wind up getting back to at least the minimum. Normal is a long way off over here. And then finally, the Yampa White Little Snake snowpack is 24% of median, with a slight decline this morning. So I just wanted to highlight the records. Things haven't changed too much, but we have seen snowpack get worse even from last month's update. So the Water and Climate Monitoring Committee meeting was on March 15th last month, and we had 46 sites which were at record low snowpack and 15 sites across Colorado which were the second lowest on the period of record, with a total of 118 snowtells across the state. And then looking at yesterday morning is when I updated this. Now we had 66 sites which were record low snowpack and 13 which were the second lowest. That's an increase of 19 sites that are at or near record low from last month's meeting. So snowpack continues to get worse, essentially. As I did last month, I always try to see if there's any bias in snowpack at the higher elevations or lower elevations. This might be a little difficult to see. Forgive me for that. Just wanted to get it all on kind of one slide. On the left is the elevation of our snowtell sites. which are represented, the snowtail sites are indicated by the dots. And then the percent of median snowpack is on the x-axis here. And basically what it tells us is if there is a positive slope to these lines, we are looking at a higher amount of snowpack at the upper elevations than is typical than at the lower elevations. So in the combined Yampa White Little Snake and the Colorado headwaters, there is a slight bias for more snow at the higher elevations. Usually that is a little bit better in some cases because it just means that that snow is going to hold on a little bit longer and it'll last later into the runoff season. This is an anomaly season or an anomaly year because we are so dry. I really don't see things changing very much from the runoff just because snowpack is slightly biased a little bit higher in those two basins. In many of the other basins, we really don't see that bias, and even this bias that we see here is not one to really write home about, mainly because we just don't have that much snow. But I think it is worth pointing out that it does provide a slightly higher chance that there could be a hydrograph peak again in some of these higher elevation northern basins, but I don't give it a very high likelihood. It all depends on how the temps and future precipitation play out going forward. And I'll get into the potential for, or the hydrographs here in a little bit. All right, moving on into precipitation, zooming again out into the rest of the country. I want to be clear here that I did remove October from the year-to-date precipitation in this map simply to remove the cooler colors that we would see in the San Juan Mountains and the southwestern portion of the state, where the storms that we received in October really seem to kind of sway the year-to-date precipitation numbers. So that's why I removed October here, is just to show how dry things have been here, particularly in all of Colorado and Utah. But things have, in terms of precipitation, year-to-date precipitation, have been a bit better in the northern half of the country. The real battle that the northern half of the country has been facing is the very warm temps. And some of my colleagues have presented how their snowpack by elevation graphs show a real bias of more snowpack at the upper elevations with near to very low snow, low to very low snow at the lower elevations in areas like Montana and Idaho. So nonetheless, we have stayed extremely dry here in Colorado and Utah. Zooming into Colorado now and looking at the full October 1 through yesterday's precipitation, you can see that bias of precipitation in the southwest portion of the state because of the October storms. But the rest of the state has, or really the entire state has stayed pretty dry with the exception of those storms in the southwest. And then looking at it from a major basin standpoint, the last graph just showed all the sub-basins and how we conglomerate those sites. But looking at the major basins, it's, as Peter pointed out, very dry on the Front Range, on the east side of the Continental Divide. On the west side of the Continental Divide, a little bit wetter thanks to some of the more recent precipitation, but still largely quite dry, but not as bad, thankfully, as snowpack is. So we have received a bit better precipitation, but it still drives the forecast down in the negative direction. I'll highlight the state of Colorado precipitation time series here, and then I have 3 sub-basin time series in here just to highlight some of the different conditions that we're seeing. But in general, statewide precipitation year-to-date for Colorado is 75% of median. You can see that we did receive a bump on April 1, and then on April 13th through 15th, we received some precipitation, but not a lot. And I'll show in another graph, in a stack graph here, where exactly that measures up for our month-to-date precipitation. Again, as I pointed out earlier, well, no, as I'll point out here in a little bit, forgive me, it's in later slides, it's those southern basins that wound up seeing more beneficial precipitation out of the early April and mid-April storms. And you can see that here in the size of the increase. And also in the Gunnison, we saw a bit of an increase. But when you look at, say, the South Platte, things were much drier. and we did not receive anywhere near as much precipitation on the Front Range here, at least on the north part. South Platte precipitation is 68% of median. Okay, so again, I'll quickly point out that precipitation from November 1 through April 20th, so not quite year to date, excluding October, is showing well below normal precipitation across much of the state. Again, I don't want to show that October piece just to make things a little bit more realistic, because that precipitation that we saw back in October continues to have decreasing impacts on our hydrograph and runoff this summer and spring. Looking at precipitation since the last Water and Climate Monitoring Committee meeting, as I pointed out, in April, we saw some pretty good precipitation there in the early portions, which has made at least those numbers in that area look a bit better, but still well below normal across the rest of the state. And then April has been a bit better, particularly in the San Juans, but still left desiring more across particularly the eastern portions of the divide. This is the stack graph. So just really quickly, here's 2026 on the left, and it is total precipitation accumulated over the year. This is the median. This is what we should be seeing each month and the total for the year. And in every single month, with the exception of October, we've fallen short. So you can see this stack here is shorter than this stack here. That means we came up below normal, and it's hard to tell in December, but we fell short there too. And in all of the rest of the months, you can tell in March, we're well below. And in April, you can still see we have a ways to go. So hopefully the 14-day outlook does play out and we wind up hopefully getting above normal precipitation. But at this point, we are, if we don't get any more precipitation through April, we will be below normal for the rest of the month in terms of mountain precipitation. Okay, really quickly, soil moisture. Again, a grain of salt to be taken with these tools, as we don't have a robust data set in terms of historical record, and not every site has soil moisture at it, but it does give an idea of at least where kind of things are. We are showing that soils are wetting up thanks to the snowmelt that we've seen already through the year. And I would add that the precipitation that we've received in some of the basins has helped. Most of it has fallen as snow, but I think it has been relatively wet snow that has still kind of melted, as you may have remembered from the time series graph. We did see a boost, which helped kind of maintain snowpack, but we also saw some melt after those snowpack increases, which has continued to wet the soils, particularly at the 8-inch sensor, and then moving down lower into the soil profile at the 20-inch sensor. You can see that the improvements are not quite as great, but we are still seeing the infiltration of snowmelt and precipitation even at the lower soil moisture levels. And the reason that most of this is above normal is because snowpack at this time of year typically has not really gotten into full-on melt. So that's why we're seeing much of these basins showing normal to above normal soil moisture, is because at this time of year, soil moisture is usually not that high. Quickly touching on reservoirs statewide, reservoirs are 89% of median. And then if you kind of dive into or focus in on individual basins, which I am not going to do in this presentation, you can see that reservoir storage is relatively near normal across much of the state, with the exception of, say, the lower Arkansas and a few of the or I should actually maybe point out, it's more Navajo that is driving this combined San Miguel de Lourdes, San Dimas, San Juan, because it is such a large reservoir. It tends to play a heavy role in the 80% as it is listed here for the combined basins in there in the Southwest. Okay, stream flows. I have a lot of these in here because I think they are valuable as people go to look at their individual basins. But I'm not going to spend a lot of time on these, but I do want to point out that the black line, of course, is this year's snowpack. I should say the black solid line is this year's snowpack, and the black dotted line is the stream flow for the particular stream flow point. In this case, this is the Colorado River below Lake Granby. I think it's basically the inflow. And you can see that from the snowmelt that we saw in late March, we did see a stream flow response on the inflow into Granby. And then things dried out. Unfortunately, we haven't been able to get an update of the hydrograph or the particular stream gauge data for this particular gauge, but I did want to show that there has been a response to the runoff from late March. So moving down into the Animas at Durango, again, we see the snowpack melt. We see more than 50% melt from the peak, and we see the stream flow responding and now subsiding with the cooler temperatures. With snowpack being less than 50% of the peak, I doubt we would wind up seeing a stream flow peak again. I would not entirely rule it out, particularly if we had additional precipitation, mostly in the form of rain. And if we had some really warm temps combined with that, perhaps there is a chance, but it's very difficult in these low years because it can be heavily driven by rain. But from a snow standpoint, there is a chance in some of these basins that that the hydrograph has actually peaked at this point. San Juan River near Archuleta, again, response. The snowpack is pretty low here. I think it's going to be pretty hard to drive a snowpack, or a hydrograph peak there. Steamboat, Yampa River near Steamboat Springs. Again, we did see an increase. It is the northern basins where I think it would be more likely to see a hydrograph peak again, but in most basins, I think we are beyond halfway through our melt, at least from the peak this year. Again, so it's really hard to determine if we've seen a snowpack. I keep doing that, a hydrograph peak, forgive me. And I'm just going to go through the rest of these because the conditions are much the same. Again, the basins in the southern half of the state have probably seen their peak. We did see the Rio Grande 30-mile bridge come up, but this one's a bit odd to me. I'm not exactly sure of their if there are operations there and what has driven this, but I do see that it has gone up kind of well after the decline in snowpack there. Okay, moving on into the last few slides here, streamflow forecasts. So this is March 1. These are the forecasts from March 1, not the most recent ones. I just wanted to show the change due to the decrease in snowpack and below normal precipitation from March 1 to April 1. You can see that most streamflow forecasts were well below normal to well below normal. And all of our forecasters and we have been continuing to provide information that these forecasts were probably going to go down based on the trends that we had been seeing. And that is, in fact, the case, what happened on April 1. The below normal precipitation and snowpack continued to decline and drove forecasts to between really 20% to 40% of normal across much of the state, with the South Platte being kind of the outlier. But I think even the dry conditions that we've seen as of late, particularly in the South Platte, are going to continue to drive these forecasts down come May 1, and I'll get into that here in a little bit. I did want to point out our exceedance projections and kind of the graphs. While you saw the map that on the last slide does provide that 50% exceedance, and that's this number, for example, here on the Purgatory River, it's that green middle number is the most likely outcome based on the information that we had at the beginning of the month. It is worthwhile to point out that one scenario is not likely to happen. There's a range of scenarios that can happen. And so that's why we put these out for each forecast point, is that we realize that it's not going to be that one outcome. There's a range. And if for example, if you have a crystal ball that tells you it's going to be drier than normal in the coming months, then you might want to go with a 70% exceedance forecast. Or if it's going to be even drier, you might want to go with a 90% exceedance forecast. And the reason we put it that way, 90% exceedance, 90% of all forecast will exceed this value, or excuse me, 90% of all runoff scenarios will exceed this value. So looking at Peter's future projections in terms of what precipitation may come, it seems like we might be looking at near to slightly above. Well, I shouldn't say that. We might be looking at some precipitation coming up. You might want to stick with the 50% exceedance forecast. I would err on the side of caution and look at the 70% exceedance forecast at this point with how dry things have been over the course of this winter, and particularly last month. Last month being such a pivotal precipitation month. So please dive into the individual basin of interest for you, or individual stream flow forecast point of interest to you. I can show you where those are at if needed. Just don't hesitate to reach out to me. So the monthly streamflow forecasts are reflected in the colored dots and how those forecasts have transpired over the last 4 months. And then there are some experimental daily guidance forecasts that we are running. These are not available to the public, but those are reflected in the gray scale here, and they're updated about every week or two, depending on the forecast point. And you can see that in most basins, particularly the South Platte and the headwaters of the Colorado, they largely continue to trend down. We're seeing, so some of these different exceedance forecasts are trending downward, and that is because of the dry conditions that we've been seeing. And even with the solid April, the early April precipitation that we saw, you can see that it actually improved, at least the inflow into Dillon forecasts. But even the forecast, or the precipitation that we received in the second week of April, really did not seem to help out very much, at least in what those automated forecasts have put out. So again, this is not available to the public, but it does help at least give us an idea of what we may expect. Now, looking at the Yampa River near Maybell, things have, or at least the automated forecast, are indicating perhaps a slight improvement through the early part of April, but we'll have to see how the rest of April plays out. So I think I've repeated some of these things multiple times. I'm not really going to go into this. Snowpack across the state of Colorado, I put this at 20% of median. That was as of yesterday morning. It's actually 19% of median as of this morning. That's down from 59% of median last month during last month's meeting. Precipitation is at 75% of median this morning. Reservoirs are up just slightly at 89% of median at the beginning of this month, but streamflow forecasts were way down from March 1 to April 1, and at this point, I would guess that they are going to probably go down on May 1, depending on what precipitation we receive through the rest of the month. So that is the end of my presentation. Thank you.
Thanks, Brian. Any questions for Brian? Thanks, Peter, for answering the questions in the chat. All right, well, if there are no more questions, I just want to thank Brian again and Peter again for your presentations. And I will have the slides on the WCMC website at the latest by the end of this week. And at the beginning of our meeting, I had mentioned the Drought Task Force website. So I'm putting the link in the chat for that, along with the WCMC website, which will be updated, like I said, by the end of this week at the latest. So I would like to turn it over now to you all to provide some updates on local conditions wherever you are. So feel free to come off mute.
Hey, Emily. This is Melissa Owens with Aurora Water. Just wanted to let you guys know that City Council voted for Drought Stage 1, and that went into effect on April 7th. Our storage as of 4/12 was at 57%. Spinney Mountain Reservoir, or Main Mountain Reservoir, was only at 48%. And we've asked people not to turn on their sprinklers till after May 15th. And I'm pretty sure, I'm in the same boat as everybody else, so I'll stop there. Thank you.
Thanks, Melissa.
Similar for Denver Water, we're on stage 1 restrictions, also asking people not to turn on their sprinkler systems until May 15th. Our storage, we're currently 79% full, but we are seeing that slowly decrease with given these conditions and the snowpack. We're going to be moving storage from one of our upper reservoirs, Antero Reservoir, that has high evaporation rates, and we're moving that water in May down to Cheeseman, where the evaporation rate's much lower. This will save us, could be up to 5,000 acre feet just by moving it down. Again, yeah, and just seeing, really low stream flow forecasts throughout our system. Also getting some interesting results from our ASO flights. So in the Blue River above Dillon, we had a flight March 20th that measured 67,000 acre feet of water in the snow. And then on April 8th, we had a second flight that only measured 40,000 acre feet of water in the snow. But during that time, only 6,000 acre feet of water flowed into Dillon Reservoir. So the snowpack's just disappearing, really low runoff efficiency, and we're just not expecting a lot this year.
Super informative update. In the past, we've had ASO present some of their findings, so we could do that again this year if folks are interested. Thanks, Nathan.
Hello, this is Adriana with Castle Rock Water. I just wanted to say that we're a little bit over 80% full for our storage. At this time, we are not in any drought restrictions, but we do foresee once we get our surface water plant up and running and do some chlorination switches, we will probably declare drought stage 1, which is voluntary, mid-May.
Thanks, Adriana.
Howdy, this is John Orr from Thornton. If you
John.
guys can hear me. Howdy.
Yes.
We are in stage 1 as of March 15th, and that's 2 days a week. Watering is the main thing. We're using AMI, and we are seeing some customers that have started watering, and we are contacting them, but our water efficiency folks said it was about 2,000 accounts out of 45,000. So largely Thornton residents are reading the drought rules and complying. So we're happy to see that. Our storage is about 78%, which is good for us and normal for this time of year. And consumption year to date is 2.53% below last year. 2.89% below last year. And so that's a good trend also. And that's my report.
Thanks, John. Good to hear that your messaging is getting across.
Good morning. I'm Walter with Highland Ranch Water.
Morning.
And right now we are about 62% full and doing well, doing okay, could be better. And currently with the elevated temperatures and everything, it's been a higher demand for us lately, about 10% higher. So right now we're on stage 1 restrictions, And we're doing voluntary hand watering right now before we can turn on, we're suggesting everyone to hand water, then turn on their sprinkler systems and stuff until May. So that's kind of where we're at right now. That's it.
Great. Thank you for the update.
Hi, I'm Beverly Richards with the Upper Gunnison. Our storage amount is about 54% for the upper basin. We had an ASO flight as well that told us there's still snow up there. It's at the higher elevations, like 11,000 to 13,000. So whether or not it makes it down, instead of just melting in place, we don't know for sure. We believe that most of our stream flows have already peaked. Whether or not we'll get a second peak is still up in the air. There are no drought restrictions in the city of Gunnison or in the county. However, some of the smaller municipalities have instituted drought restrictions, and I think they're in the drought 1 phase. And I think that's about it. We're looking at stream flows. We're really thinking that our stream flows are going to be 30 to 50% of normal in the basins. So we're already seeing water administration for tributaries on the Gunnison River. So it's pretty dry up here, but hopefully the cooler weather will stave things off a little bit. Thank you.
Absolutely. Thank you, Beverly.
Oh, and I forgot, we did hear this week that we would not be getting a drawer release out of Blue Mesa, so that we're very thankful for that.
Great. Thank you.
Hi there. Joe Pitty, Little Thompson Water District. Just want to chime in. One of the water providers whose supply is largely CBT, and the quota was issued from Northern Water at 80%. Yeah, that put us in a really fortunate spot with our water supplies. We're able to rent about 2,500 acre foot to local farmers and ranchers. So we're really happy to be supporting them this year. As far as drought restriction goes, we're not entering them at this time. We released a letter to our customers kind of explaining why that is. And we are super excited to be signing on to kind of a group letter that's being put together by the Colorado Drought Coordination Group, who's meeting tomorrow. Yeah, that's probably everything from our end. Thanks.
Thanks, Joe. Anyone else in the last couple minutes here? Appreciate all of you chiming in today. All right, well, looks like that's all for today. Thank you all for your time. Thanks to Brian and Peter. And our next meeting will be on May 19th. So I will see you all then, and hang in there. Thank you all.